So we'll see what happens. Today we do a quick, maybe 10, 15-minute teach piece on everybody's friend, the parabola. Everybody's favorite friend, the parabola. So let's play with one of our favorite parabolas. F of x equals, consult Mr. Lesson Plan. Mr. Lesson Plan, hey, Mr. Lesson Plan. This is the parabola x squared minus 4x minus 7. You see it all the time. You can't go to Wegmans without seeing it. It's a very important parabola. And so I want to do a couple of things. I want to find its vertex, and then I want to find its intercepts. I want to find the vertex, and I want to find the intercepts. Intercepts are pretty straightforward. You're already able to tell me that the y-intercept is at 0, -7. Go ahead, tell me how you know it's at 0, -7. Because I said so, and I'd never lie to you. I would never lie to you, except for that one time. Except for that one time. So there's 0, -7. How do I know that? At the y-intercept, the x value is 0, and so you substitute 0, and there you go. Yay! But first things first, we've got to find ourselves a vertex, and so I want to figure out where the vertex is through a process known as, well, it's not a big secret now. It's on the board. Completing the square. I want to complete the square, so I got to remind myself what the heck I meant by completing the square. So I think in the whole completing the square process, we left a gap after the linear term and before the constant term, and we did that so that we could add and subtract the same number, and we did that so that that's right. We want these three terms to be a perfect square trinomial. We want these three terms to be x blah blah squared. Not blah blah blah. That's the girl in the Biz Markie song, You Got What I Need. So this would be blah blah, not blah blah blah. That's totally different. So what we do is we add a magic number and we subtract a magic number. I haven't used that one yet this year. Nice line, Ritter. Nice line. Question is, how do we find the magic number? What do we do with this to get us there? Wow, the microphone's really not going to pick that up. Nice and loud. Yes, 4. Why? Yes. I'm going to say no. Stephen is telling a story about the New York State Math League Championships where in a relay, a math relay, he passed a whole bunch of 4s back to the person behind him to encourage him, yes, 4 is the answer he should have. And then when that person tried to stuff all the 4s into his hood, that was viewed as forward communication, which is, of course, not allowed and should probably have been disqualified. But what are you going to do? That's Stephen Herr, folks. H-E-R, Herr. If you're looking for Facebook friend requests, that's where you look. Halve and square. We halve and square. Half of -4 is -2. Squared is 4. And we do that because that allows us to write x minus 2 squared right down below. But, Coach, you can't just add 4. That's right. And that's why we subtract 4. And if I lose 7 friends and lose 4 more friends, I have lost 9 more friends than I've ever had. Where's the vertex? It's at 2, Negative 11. The first one reads counterintuitive. The second one reads as is. You may remember in the definition of a parabola function that we had talked about, the general equation is x minus h squared plus k, where hk is the vertex. So the first piece reads in a counterintuitive way. The second piece reads in a not counterintuitive way. Find intercepts. We've got y-intercept already down. Got to find x-intercepts. And to find x-intercepts, I'm just going to take advantage of that thing I've already got. I've already got this thing in a nice form. And since I've already got it in a nice form, I'm just going to use it. Some of them want to use you. Some of them want to be used by you. How do you solve from there? It rhymes with bare newt. Very good. A bare newt, by the way, is a newt that isn't obeying the dress code. Goes right in front of there. What goes right in front of there that you've missed? Rhymes with pus or sinus. Very good. Very good. You're all like, will there be rhyming clues on final exam day? No. Need x by itself. How do you get rid of minus 2? You add 2. And there it is. So the x-intercepts are at 2 plus root 11, 0, or 2 minus root 11, 0. Everybody say yay! Gosh, I hope the mic picked that up. They actually said something. That's marvelous. Can I do that to you one more time? Do that to me one more time. Do it again. Oh no, there's a 2. There's a 2 in front. We'll never succeed. Oh no, there's a 2 in front. We're doomed. We're destined to fail. Not really, because we're mathematicians, and mathematicians always reduce problems we cannot solve to problems we have previously solved. If the 2 is the problem, then we just... That's your solution to everything, isn't it? The banana becomes a problem. You just eat the banana. I get it. I get it. I get it. I get it. Whatever happened to that banana, Nick? Oh, wait, Nick ate the banana. Poor guy. Poor guy. Suck out a 2. You suck out a 2 and you say, you know what, 2? You stay away. I'll deal with what's inside. So I need a magic number to add and subtract. Give me a magic number. It's a fraction. You'd have to have 3 and square it. I don't know what half of 3 is. The folks at home are now screaming at their computer screen. Half of 3. Half of 3 is 3 halves. Square it. 9/4. This is why the 4th period group always gets more done. Because they have Ben Bozek. B-O-S-E-C-K. Ben Bozek. So there you go. You got that going on. So who is it? It is 1.5. Then we square that. We get 2 1/4. So here we go. This should be fun. Amuse me, gladiators. The first three terms are x minus 3/2 squared. 1/2 minus 9/4. Go ahead, subtract the tops and then subtract the bottoms. Go ahead. I double dog dare you. Please say negative 7/4. So now all that's left is for us to be a good socialist and distribute. There's your distribution on your first part.
Don't we distribute the 2 through the parentheses?
No, falsetto boy, that's a terrible idea. We never distribute through parentheses when there's an exponent on those parentheses. It breaks the order of operations. Let's see. 7/2. Rhymes with heaven calves. Very good. Very, very good. Where's the vertex on that thing? Let's see if we learned anything from 5 minutes ago. Where's the vertex on that thing? That's right. 3/2, and there it is. There it is. Of course, if the paper were green, if it were calculator active, you'd just graph the stupid thing and hit second calc, find a min. You could do that too. Of course, the paper is not green. So there. What if I'm looking for intercepts? Clearly the y-intercept is at 0, 1. To get the x-intercept, we'd have to set that function equal to 0. Let's do it the old-fashioned way. Let's see if this early in the morning we can sing a song, sing out loud, sing out strong. X equals negative b plus or minus square root of, everybody.
Oh, baby, you got what I need. You said he's just a friend. You said he's just a friend. Oh, baby, you got what I need.
I don't know if on our school website we can like videos and dislike videos. I'm going to dislike this one. I'm going to dislike this one. For the folks at home who couldn't hear the song, I'll put the song over in the cloud. The song is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. But my first period class really likes that Bismarcky guy, so they sing differently. And if the microphone didn't pick them up, then, well, you have no idea what I'm talking about. There we go. What's inside the radical? It's inside the radical. Right. Right. And so we've got 6 plus or minus 2 radical 7 over 4. Now we should probably talk about how things cancel from there. How do things cancel from there? 2 goes in a 2. 2 goes in a 4. 2 has to go into 6. We either have to take from everybody or not at all. We have to take from everybody or not at all. And so this turns into 3 plus or minus root 7 over 2. Can I say one other quick word about the quadratic formula? There's this part here in the quadratic formula. Do you remember what that's referred to as? That's the discriminant. It's the discriminant because it helps us discriminate between types of quadratic equations. if the discriminant is greater than 0, there's 2 real roots. And if the discriminant is equal to 0, there are 2 roots, but they're the same. And if the discriminant is less than 0, there are no real roots. And so they like to throw questions out at you that say, here's a quadratic equation, there's some k in the middle of the equation. For what values of k does the equation have? 2 roots, or no roots, or 1 root? And so you crank that out, and I'd do that if we had time, but Bismarcky took from our time. So there. And that'll be that. So that's our teach piece for first period. More later.